Hello, gorgeous. Let's get started. Okay, so we move on from skill 1, functional group transformation, to skill number 2, moving functional groups. Okay, all right, I got 2 examples right here. So when you add things on an alkene, let's say we're adding HBr, you got options, right? You can add bromine onto the more substitute carbon. Okay, this one gonna move your functional group to the left side. You can add HBr bromine onto the least substitute carbon. This one will move your functional group to the right side. Okay, there's a left and right. Now, the other example, this one for elimination, okay? You got options too. You can elimination, put double bond right here on the right side and doing Zysave product, okay? Move the functional group to the right. Or you can move to the left, do a Hoffman using big bulky bases, okay? So, put this together. This is how it's gonna work. Take a look. Okay, we can move the double bond. Okay, we'll try from this to this first, like right here. Okay, so all right, looks like we have to move the double bond up. Okay, that direction. This is what you're gonna do. You're gonna try to put leaving group on to that carbon. We're gonna go up. Okay, so first off, we're gonna add HBr. Do you know where bromine gonna go to? On the more substitute carbon. Okay, all right, from here to there looks like you have to do Hoffman. This is going to be Hoffman product. Okay, so add big bulky bases, third pentoxide. If you do addition, elimination, addition, elimination, alternate, okay, in this manner, the result is moving the functional group. Okay, let's try one more time. I'm going to go from top to bottom right there. Okay, so we have to move the double bond down south. Okay, all right, let's see. So it looks like I want to put the leaving group right there on that position. That's an anti-mechanical position. That's a product right there. Okay, and then double bond right there. Let's see. So small base there, bulky base there, big base. So add a big base. Yeah, so we're moving a double bond. Okay, let's try moving the leaving group. Okay, you know how to do this. All right, let's see. So let's go from the top first. Okay, left to right first. Let's see. So it looks like I want to move to the right side. Double bond right there. So this is Zysave. Use small bases. Sodium hydroxide works just fine. Sodium hydride also work. Okay, double bond gonna go right there, and then put bromine on the more substitute carbon. This is mechanical fashion. So I just add HBr. Because if you add the peroxide and light too, it'll go back. Okay, all right, let's go down here too. So it looks like we have to move the leaving group to the left, to the left, to the left, to the left. Okay, put double bond right there on that position. This is as I said, that's a Hoffman, so big bulky bases, Hoffman product. Okay, and then put bromine on the least substitute carbon. That's gonna be HBr, peroxide, and light anti-mechanical carbon. Okay, if you add just straight HBr and go back right there, you know. All right, that's skill number 2. Let's use it. Okay, all right, so we have this one. Let's see, move double bond to the right side. Okay, try on your own first. Okay, and then check with me. Double bond right there. Looks like we have to do elimination. The leaving group, there's no other option, gonna be right there. Okay, so you can put double bond next to it. All right, so for sure you're gonna make this compound, gonna go through this intermediate. Now can you see the connection between the starting compound and this guy? Yeah, that's the anti-Markovnikov hydrobromination, you know? So we start adding HBr, peroxide, and light. Okay, you're gonna get this, and then do elimination. So small base gonna go there, bulky base gonna go there. Looks like I'm gonna use bulky base. Third butoxide, aldehyde works. Okay. All right, part B. So we have to move the functional group there to the left. Okay. All right, let's start with the product first. Look at this compound. If the OH right there, there's a few reactions on alkene that allow you to put an OH, okay, on an alkene. Okay, so if you want to put an OH right there on that tertiary carbon, the alkene that you need could be either this or that. You got 2 options. Okay, both will put OH group right there on 2 Markovnikov carbon. Okay, now starting compound might be easier to go from here to there than go from here way over there, because this double bond is way too far. Okay, so I'm gonna try to get from this guy to that first. How do you do? You can do an E1, so we have dehydration, put double bond right there. Or you can convert the OH group to a better leaving group first, HBr, TSCl, and pyridine. Okay, either or, and then small base. Okay, or any type of base work here. Okay, strong base, put double bond right there. All right, and then we're gonna add water. So Markovnikov carbon. So we're gonna go with oxymercuration, demercuration. Okay, you can also use the catalytic hydration too, but that one go through a carbocation and rearrangement could occur. Okay, not the case for this one, but for synthesis we try to be sure. So I'm gonna go with this one. Okay, all right, we got 2 more to go. Let's see what are we doing right here. Okay. This is syn dihydroxylation, okay, which means that the before you make this compound, the double bond gonna be on that position. So the question is, can you move that double bond to that right there, that position? Yeah, you can. I'm sure. We do addition reaction, elimination reaction, addition reaction, elimination reaction, alternate like that. Okay. All right. So we're gonna move down south right there. So put living group right there. Addition reaction first. So just straight HBr. Okay. And then put double bond right here. So we use small bases: sodium hydride, sodium hydroxide, sodium methoxide, ethoxide works. Okay. Right there. Once you get double bond right here, now one more step: osmium tetroxide and enamel. Okay. All right, let's go to part D one more time. So if you recognize that this is anti-dihydroxylation, this is gonna pop up on your head, MCBBA, and then pop the ring open, epoxide open. Okay, so looks like we'll need the double bond right there, which means that you're gonna move the double bond down south right there. Okay, all right, put the living group right there first. Addition reaction, straight HBr. Okay, followed by put double bond right here. So you will need small bases. So sodium hydride, sodium hydroxide, ethoxide, methoxide works. Okay, so the major product is the side product. Take the major and move forward. So we'll start adding MCBBA. You're gonna get to the epoxide on wet and wet, that and that. Then pop the ring open. Water attack on a more substitute carbon. Doesn't have really more substitute carbon, so it doesn't matter right here. You get that's product. Okay. All right. Let's practice them more together. Okay. So the next one on your own, and check with the answer with me on the next video.